be mod, so let's keep mod for both. Then what is the formula? 1 minus heat rejected is equal to, so this should be equal to N CV T4 minus T3. N CV T2 minus T1. Let me find out efficiency. We have only this, but temperatures are not given. We assumed it, no? Here. So this NCV will get eliminated. So altogether this will become T2 1 minus mod of this will be T4 will be less than as it is a mod, no, we can adjust it T3 minus T4. Okay, now we don't know temperatures, what to do. I'll take help of adiabatic gas equations. So this will be T1, I'll start with the T2 V0 gamma minus 1 should be equal to T3 NV0 gamma minus 1. With the help of this, I can replace the temperatures. Let me write one more equation. This will be T1 V0 gamma minus 1 equal to T4 NV0 gamma minus 1. T2 minus T1 is there. We'll take the difference of these two. Okay, now we have the equation V0 gamma, that will get, so 1 by N gamma minus 1 equal to, substitute that there, so the efficiency will be okay, simple. Now let's go for equivalent graphs. Very important, anywhere can be asked. Let's plot the equivalent graphs. First I want the pressure versus temperature versus volume graph. Rough graphs, temperature versus volume. So volume of gas, here it is V0, eta V0. Temperatures, adiabatic expansion. What do you expect temperature in adiabatic expansion? Q is 0, work done by gas, temperature should decrease, no? So T3 will be less than T2. We have to be very careful in giving the symbols. In adiabatic compression, T1 will be greater than T4. In isochoric process, so if pressure decreases, temperature should also decrease. So what is the order here now? How we should take order? T2 should be greater than T3, T3 should be greater than T4, T4 should be greater than T1, or T1 should be greater than T4. Temperatures we need now, which will be greater higher temperature. T2 greater than T3, no doubt. Because in adiabatic expansion, work done positive means intensity decreases. So T2 should be greater than T3. Then in isochoric cooling, pressure decreases, volume should decrease. So therefore here I have T3 greater than T4. Adiabatic compression, work done negative, intention should increase. So T1 greater than T4. Then in isobaric heating, pressure increases, temperature should increase. So T2 greater than T1. So we have to get now relationship, because we have to indicate here on the graph the temperature, which is a 1, which is 2, which is 3, which is 4. T2 is greater than T3 and also greater than T1. T1 is greater than T4. So can we say anything about T3? At least I am very sure that T2 is greater than T4, no? Looking at the graph. Looking at the graph, okay, this is enough. So T2 lowest is T4, highest is T2. And relation between no, we'll write it. This is T2, this is T4. Now between 3 and 1 we have to decide. We can't very sure, no? So here looking at the something, they may be same, or if you look at, if they are at same horizontal line, pressure will be same, volume here more, then T3 should be less than, suppose if 1 and 3 are on same horizontal level, pressure will be same. Use ideal gas equation, PV equal to nRT, T equal to PV by nR. Pressure is same, volume of this is more, no? So T3 can be greater than T1 here. If 0.3 lies below, or if it is above also, it will be that one. So we'll just assume, just to have a rough graph, this one T3, this is T1. Now you indicate the points. Point 2, temperature T, volume is V0. Point 3, temperature 3 and volume is point 4. Point 4 is temperature 4, volume is eta V0. Next there's a 1. No, path 2, 3. First we'll go for isochoric process 1, that will be much easier. So this is 2, 3, 4, 1. 3, 4, isochoric cooling, vertical line. 1, 2. What to do with 2, 3 and 4, 1? Adiabatic process, temperature versus volume graph. TV gamma minus 1 constant, say alpha. So if I differentiate this, T gamma minus 1, V gamma minus 2, dV plus V gamma minus 1 dt equal to 0. dt by dv is what needed for us. Okay, this will be gamma minus 1 t by v equal to minus of dt by dv. Check it once. This is the expression for dt by dv, the slope we have in terms of t and v. What do you can say about the There are only two things are there. Either the curve will be like this or should be like this. Which curve is what I should take? Negative slope is needed, no? The slope is negative. The total slope should become negative. So negative slope means here I'll go for something of like this. Okay, equivalent graphs can also be asked. You have to be very, very, very careful.